Hello and welcome to this session on Cisco Access Control Lists or ACLs. So this session is relevant to Cisco CCNA exam and a foundation to CCNP, and during which we will cover ACL overview, a broad view on ACLs, filtering of ACLs, the logic behind ACLs and how you build your ACLs configuration, where to put your access control lists. We will look at the differences between standard access lists and extended access lists. And we will also take a look at wildcards, how to understand the wildcards. And finally, we'll finish off with a demo lab as usual. Access lists are a mechanism used for filtering and catching traffic. When applied on a routed interface, you use ACLs for the purpose of permitting or denying traffic between given hosts or subnets or between certain TCP ports. So these access lists are applied to ingress or ingress layer 3 ports. So in this particular example, if I want to, for example, allow this particular host here, this PC, to reach this web server and deny this PC2, for example, to reach this server, I will have to use an access list that will allow traffic from this PC and deny it from this one. So you can think of access list as a form of some sort of firewall allowing and permitting traffic based on certain criteria, and these criteria are the subnets or IP addresses of the hosts, and also a combination of TCP port for the extended TCP or UDP ports for the extended access list, as we will see in the next examples. Access lists are also used for catching traffic for the purpose of quality of service classifications. So for example, this is an IP phone and I would like to prioritize the traffic for this IP phone here. So what I will do, I will have an access list very likely on this router 1, that will look at the traffic coming in from this phone and put it on a class map, which I will then prioritize. So in this particular case, nothing is permitted or nothing is dropped, but it's purely catching the kind of traffic so I can classify it and take further action afterwards using my quality of service policies. Another way access lists can also be used is for securing certain services. So say, for example, this is an SNMP, a polling server, or an NTP server. I would like, if I'm using NTP here, I would like to ensure that the IP address of this server is the only one that is permitted for synchronizing my network time protocol. I also would like to have this SNMP server on router 1 to be the only one allowed to poll R1 router and gather MIPS data. So there are different ways that access lists can be used, but for the purpose of this session, we will focus on the first parameter here, or first way of using access lists, which is filtering and securing. When you're writing or building your access list, there is a logic to it that you need to be very, very aware of. So a packet will come in this direction. Let me just change the color so you can see it better. So you will have a packet coming in on this direction here, and the packet will land or will ingress or will come in through this interface on this router 1. And here you will have an access list that is defined with certain criteria. For example, it would be permit the packets or the flow if from subnet X, deny the traffic if it's from subnet Y, permit it is from subnet Z, and so forth. So this is what the access list will broadly look like. So you'll be a list of statements that are in a certain sequence. So depending on the type of access list that we're using, the packet source or destination or ports would be passed against each line on this access list. And as soon as there is a match, everything stops. A decision has to be taken there. So for example, if the first packet matches the permit or matches this statement, then this is the decision that will be taken, which will be permit this RP packet. So it's very important to understand that as soon as there is a match, the process for that particular packet stops. In this logic, it is also very important to understand your traffic flow. This will give you an idea about where is best to put your access list. Is it best to put it ingress as the packet is coming in on an ingress port? Or do you put it, for example, if there is another, of course there will be another link here to another cloud, a domain or router, or would you put it egress in this direction? So it's important to have these factors in mind so you make the right design and the right decision. Another important thing is that on a given interface, you're only allowed to have an access list in one direction. So it's either inbound or outbound. You can't have two access lists, both of them inbound or both of them outbound. And this is per protocol. Okay, so this will apply for IPv4. And if you are running IPv6, you also allowed to have another set of access lists, one inbound and one outbound if there is need for it. But you cannot have, for the same protocol, two access lists in the same direction on that same port. That's another thing. And finally, when you're writing your access list statement 1, 2, and 3, and so forth, there could be 100 lists for this access list. There is always an implicit deny. What does this mean? That means if you don't write anything at the end of your list, the access list will drop all traffic. So be careful with this in production. So you could be, for example, filtering traffic from subnet X as a deny, then allowing traffic from subnet Y, and then you think, okay, my access list is finished, let's apply it to the interface. Once you do that, you actually block in the traffic from all the other subnets, Z and what have you. So this is very important to remember. If you don't permit the traffic at the end, the rest of the traffic at the end of the access list, the action taken here will be a complete deny of traffic. Okay? So to recap on this point, access lists are sequential. That means they are in a sequence, and action or parsing will be done in that same sequence. When an RP packet comes in, it will actually be compared to each line, and if there is a match, the process stops and the action is taken. The access list is not effective or doesn't take effect until you apply it to the interface, either inbound or outbound, as required by your design. So you can write your access list statement, but it will not take any effect because it is not applied to an interface yet. Third point, you're only allowed per protocol one access list per direction, inbound and outbound for IPv4 and the same for IPv6. And finally, if you don't put anything at the end of your access list, there will be an implicit deny. This is very important. So speaking about directions, and just to consolidate what we have spoken about on the previous slide, let's say, for example, you want to allow PC1 to reach server 1, but you don't want it to reach server 2. So you'll have to think about where is the traffic coming from? How does the traffic flow from PC1 all the way to server 2 so you can actually block it? So you can actually put an access list here. You can put an access list here outbound. You can put it here. You can put it here. There's different ways you can do it, but not all of them are optimal, as we will see later. So for example, is very clear there is no point putting an access list in here because PC2 has nothing to do with this requirement of blocking PC1 to reach server 2. So there's no point putting an access list on this interface here on router 1. So let's give this PC an IP address of 172.16.1.10, and let's go through the process of where is it optimal to apply the access list. So how should my access list look like, for example? It would be something like block or deny 172.16.1.10 and then allow all. So it's two statements. So let's have a think. If I put my access list at this point here, ingress, what would happen? I will block all traffic that is coming in from this PC. So my PC can't reach server 1. So this is not the best place to be. Same if I put it outbound on this interface, because the traffic from here is exiting the interface. Therefore, it has to be applied outbound. Here, the access list has to be applied inbound. So same story here. If I put my access list here, I will actually drop all traffic that is going to server 1 and server 2, because that's what my statement says, that the packet will come in and it will match this IP address, and the action is to deny. So putting the access list on router 1 is pointless. Let's take a look at router 2. If I put my access list here, that will have the same effect, undesired effect of dropping all traffic that is coming to server 1. So what about putting my access list here on gigabit 02? The traffic is flowing this direction from PC 1 and then down to this server here, server 2. What would be the action taken in router 2? Looking at the access list, the IP packet from PC 1 will match the first line, which is a deny. So this will deny traffic to server 2. Therefore, I will not reach server 2 from PC 1. And then the second line is to allow all traffic, meaning that PC 2 will actually come in and be able to reach server 2. PC 2 will be able to reach server 1. PC 1 will be able to reach server 1. So the optimal placement for this access list, for this assignment, is to actually use gigabit 02. So looking at this statement here is matching an IP address, a source IP address. That's all what is matching. This type of access lists are called standard access lists. You will be matching either a host IP address, so a /32, or a subnet, but it will always be a source, either host or subnet. And the best place for the ACLs of this type is actually as close as possible to the destination. Let's now look at a different case or a different way of doing things. We're still looking at PC number 1, which is allowed to reach server 1, but not server 2. So this is fine to reach. And we don't want to put our access list on gigabit 02 as we did earlier using the standard access list. So here there is a different way of doing things using extended access list. And the beauty of extended access list is that you can use a combination of source and destination. So as a first statement, I could start by saying deny PC1 to server 2. Second statement is permit any traffic to any traffic. So I'm allowing PC1, or I'm denying PC1 to reach server 2, and after that any other packet can go anywhere else. So any packet that is coming in or seen to be coming in from PC1 towards server 2 will be denied. Anything else will be permitted. So where can I put this access list? In this particular case, the optimal place to put it could be gigabit 01, and it would be ingress, because the traffic is coming in this direction. It would be caught on this interface, and if the access list sees, passing the access list sees that there's traffic coming in from PC1 to server 2, that would be dropped immediately. Any other traffic, so Obviously, we only have one PC here. We could have a multitude of PCs. It could be a LAN. So this traffic will be permitted because it doesn't match this condition. So using extended access lists gives us this benefit of being a little bit more selective about the kind of traffic that we want to match and take action on. So let's just recap on these two types of access lists. So we have the standard access lists, and they are numbered, they could be numbered, and they will start from 1 to 99 and 1300 to 1999. They could also be named. This is a very interesting concept. That means that when you write your access list, you can give it a name that makes sense to you. So when you are troubleshooting or your colleagues are looking at the configuration, they will understand what is the purpose of this access list. It does help. As we have seen in the previous example, standard access lists act on source IP address. Syntax-wise, this is how the access list can be configured. There's two ways you can do it. You can either use access list 10, giving it a number, permit a host. So either you can write host, or you can write the IP address followed by 255, 255, 255 all the way to define a host. And a second statement will follow straight after. You write exactly the same thing. Access list 10, deny. In this case, we're denying a subnet, and this is a /24. Be mindful of the way this network is written. So it's written the opposite way you would normally write a network. You know that for /24, the subnet is 255.255.255.0. But in this particular case, we're using the opposite, and this is called a wildcard mask. So we will take a look at this one in the next slide. So this is one way the access list, standard access list, can be written. I prefer to write it this way because it gives me a better view of things. So I'll write RP access list standard and give it a number, 10 in this case, and then I'm in the access list configuration mode, and I'll start putting in my statement one after the other. Remember, again, up to this point where you finish writing your access list, no action has been taken. So the action will be taken after you have applied your access list to a given interface. And the format will be, or the syntax will be, IP access group 10 to refer to the access list you have written, and then inbound or outbound depending on your design or whatever you want to achieve. So this is kind of a very brief idea about standard access lists, and in fact this is all what you need to know about standard access lists. For the extended access list, it also comes in different flavors, the numbered and the named ones. So the numbers allocated for access lists are 100 to 199 and 2000 to 2699, and they can also be named. And as opposed to the standard access list, as we have seen earlier, the extended access list will act on source, destination IP address, as well as ports, which gives us a little bit more granularity and more control of the type of traffic that we want to take action on. A sample of a configuration would, for example, be access list 101, deny TCP port. It could be UDP for traceroute, for example, or what have you. TCP hosts, I'm matching this host to another host. And what kind of traffic do I want to match? HTTP traffic. And you will have a whole selection, as we will see later on in the demo, of protocols that you can match on. Remember, we spoke about wildcards. So there's a very simple technique how these things can be written, or how to get your head around it. So I have this subnet here that I want to put in an access list format. What you have to do when you come to write it, this is basically a /24. So you take your subnets and you subtract it from a full 255, 255, 255, 255. So this will give you 255 minus 255, that's a 0. This will give you 0. This will give you 0. 255 minus 0, that's 255. So this will be what you put in on your access list, which is your wildcard or reverse mask, one way to look at it. Another example. So you have here your /28, 255, 255, 255, 240. You subtract it from 255, 255, 255, and your result will be 0.0.0, and then a .15. And this is how you will write it on your access list. I hope at this point you have managed to get a good idea about access lists, the logic behind creating access lists, where to place them, and the differences between standard access list and extended access list. To solidify this knowledge, join me on the next session where I go through a demo lab sharing with you configs and troubleshooting methods. Thank you for watching and see you on the next session.